In this video, we're going to talk about copper reaction 4 and 5. So in reaction 4, we're going to change copper oxide to copper 2 chloride, and then in reaction 5, which is on the next page, we're going to be changing copper 2 chloride back to solid copper. So in today's lab, we're going to get back our solid copper that we started with. Now the form of it's going to look a little different. We're not going to get it back in a wire, but we are still going to get solid copper back out. So let's take a look at reaction 4. In this reaction, we'll combine the solid copper 2 oxide with hydrochloric acid to form copper 2 chloride and water. So just like before, you'll write out your equation with the chemical formulas, balance it, and assign states of matter, and this will match up closely to one of our types of 5 reactions. For our experimental procedures, we'll notice that we have some pre-work to do before we can actually start getting our copper oxide. If we look at our beaker has our copper oxide as solid at the bottom, so down here is our solid copper oxide, and then above it we have the liquid left over from last time. If we check back the liquid left over from last time, from our reaction, if you look here, we made copper 2 oxide and water. So that top part of our beaker today is just water that's hanging out there. So the materials that we'll need, it says that we want to record the physical descriptions of the products from reaction 3 above, so we record what our beaker looks like, then pour off the extra liquid from the beaker without losing any of the precipitate. This procedure is called decanting. To decant, we will need a stir rod, so if you want to add that in, we need a stir rod, and we need a large beaker to pour off the liquid we want to decant off, and I'll show you how to do that. It then says we also need to add approximately 100 milliliters of distilled water. So we need to add distilled water to the beaker to gently wash the precipitate. We'll let the beaker settle for 5 minutes and then decant the distilled water, leaving all the solid in the beaker. So I'll go ahead and show you how to do that. Decanting can be a little tricky, and it takes a little bit of practice, and you might lose a little bit of your solid here. That's pretty normal, but it'll get easier as you practice. So it's super important to have your solid be at the bottom, in this level at the bottom, and then have all the clear liquid be at the top. So if you can kind of see how it's just water at the top and your solid copper 2 oxides hanging out at the bottom. So what I'm going to do is take my stir rod and I'm going to place it over the top so that way it comes along kind of the opening there. And then I have my other beaker here. And I decant into the other beaker in case some of my precipitate comes out, I can catch it. So I'm going to take my beaker and I'm going to pick it up and kind of hold the stir rod on the top and on either side. So I kind of have it, like this. And I'm going to tip it up and I'm going to have my water is going to run down the stir rod and into the beaker, and my solid is going to stay at the bottom. So I'm going to flip over here so you can see me a little better. So I'm going to pour, and the liquid is going to come out, but my solid is going to stay at the bottom. And you want to do this really carefully, so that way you're not disturbing any of the solid at the bottom. See the solid starting to come closer to my stir rod. And you can see it started to come off there. Okay, we don't have to decant all of it right away. So if I look, I can see that I still have some water in the bottom. Now on our next step, it tells us that we're going to wash our solid. That's step 7. So what I'm going to do then is I'm going to add in 100 milliliters of water, and it's just approximate. So I see that I'm at about 50 milliliters here. So I'm going to take my wash bottle here, and I'm just going to add in, so it's at about the 150 mark. So after I add that, it tells me to let it sit for 5 minutes. So for 5 minutes, I'm going to let it sit, and that's going to let my solid kind of settle down to the bottom again. Okay, and then I'd repeat that process to decant. So while that's settling, we'll talk about the next steps. The next steps of the lab it asks us is to actually do our reaction. So we're going to then react our copper oxide, that black solid, with our copper 2 chloride. It tells us we need to measure out 30 mils of 2 molar HCl in a graduated cylinder. So I need 2 molar hydrochloric acid. I need a graduated cylinder. It tells us we're going to add the hydrochloric acid to the black copper oxide in the beaker. Stir gently. The oxide will react, leaving a solution of copper 2 chloride. So in the hood, again, you will find our hydrochloric acid. That'll be in our bottle here, and I'll have it in a beaker for you to then pour into our graduated cylinder, right? And so I'm going to fill it with 30 milliliters, okay? That is going to get added to the solid copper oxide, so this will have been decanted, and just the solid will be at the bottom, and I will swirl it, okay? Then I will move on to reaction 5. So I will record the name and physical description of the product, record any whoops, and also any chemical changes. And then reaction 5, we're going to take our copper 2 chloride, which is dissolved in solution, so it's going to be aqueous again, and we're going to get it back to copper. So if we read, it says, in the reaction, we will react the copper 2 chloride solution with aluminum wire, forming solid copper, once again, and aluminum chloride. Because there will also be hydrochloric acid left in the beaker from the previous reaction, you will see a secondary reaction as the hydrochloric acid reacts with aluminum, forming hydrogen gas and aluminum chloride. So we're going to write 2 reactions, the primary reaction happening with the copper, and then a secondary reaction as talked about up here. So both of them are similar types of reactions, so you'll write that. For your experimental procedures, again, you'll record physical descriptions of your products, and it asks you to find or to obtain 1.5 grams of aluminum wire. So we need aluminum wire. It says to bend the wire in half until it is as long as a stir rod, then bend into an L shape, and I'll show you that, so that way it'll fit into your beaker. It says to place the wire in the beaker and immediately cover with a watch glass and record all observations. Shake the wire to dislodge the copper, allow the beaker to stand overnight, and the absence of bubbles will indicate the reaction is complete. So the only material that we need for this is aluminum wire. Your aluminum wire that you get is nice and long, okay, and I folded mine in half. You're going to fold it down and in half until it gets to be about the length of a stir rod. So here's my stir rod. They're about the same length. You could even fold it one more if you wanted. We're going to have just a handle, so we're just going to have one of these sides come up. Then we're going to bend this other part down, and we're going to turn it into, so this is like my handle portion. We're going to turn this into an L. Okay, so that means that this is where our copper is going to form. It's going to form on our, here's our L here. Our copper is going to form on this aluminum, and we're going to put that down into our beaker. Okay, so in our beaker, we are going to so if this was my beaker, I would put my aluminum, and this had my copper in it. I'd stick just my aluminum down inside, then I stick my watch glass on top. Okay, the copper is going to form on the aluminum wire, and I want to dislodge it, so as it's forming, every once in a while I'm going to shake it against the side, and that's going to help the copper fall off. Then what we'll do is we'll let that set overnight, and then the following day we will decant off our liquid and then collect our copper.